my children, today we'll do the most important topic in physics that has come out from Faraday's laws of electromagnetic induction, in which the whole world get the most beautiful result, and that is generation of electricity. So, a summary of what we have done. Whenever there is a rate of change of magnetic flux through a coil, there will be an induced EMF. Remember that. 2. The magnitude of the induced EMF is directly proportional to the rate of change. So, let's see here now. This is the frame of the point where I will wind. See, I'll start from here. I will wind a wire, a coil. Okay, this is area A. If I wind one single turn and come back here, so it is A. But if I wind 50 turns and come back here, the area is increased 50 times. And if this is the flux, if this is the magnetic field, the flux will be increased 50 times, 50A. So this is the beauty of this. So here there will be some machine to rotate this. Now there are two ways of getting electricity. A coil may be fixed. I drop a magnet. I put it up and down, up and down. I'll get electricity here at the two wire there. I'll get electricity. Or a magnet will be fixed. Suppose now this is north, this one is north, this one is south. So see, this is north, this is south. So now this is the area. When it is like this, maximum flux is getting. When it is like this, see, 0. When it is like this, maximum area. When it is like this, 0 area. So today we will do with what? The magnet fixed. See, the magnet is fixed, and this one is rotating. See, it's rotating like this. So here now, in your book, in CBSE book, you should have seen beautiful diagram. 1, 2, 3, 4 diagram. See, when the coil is when the magnetic field is perpendicular to the plane of the coil, we are very surprised. See, the voltage is 0, and when the magnetic field is parallel, that means the area is 0. See, when it is parallel, the area is 0. But it is maximum, perpendicular, 0 again, and now this one will be minus. Why? Because this PQRS have turned from here to PQRS. The two phases are different. See, 0 here and 0 here, they are different. Why? One is plus, one is minus. So see here, this is the coil, 50 turns, say, I have told you, and there is a ring. One end of the coil has one ring, one end of the coil has another ring, copper ring. Very nice, good conductor. And here is carbon, and there will be a spring to push the carbon. There will be a spring to push the carbon, and from here you will get the voltage. See, all of this have got the same thing. You can look in your in your smartphone also. So now, that is very, very mysterious. Right angle, the area is maximum, 0. 0 area, maximum. Then here also, maximum area, 0, 0. Why? There is one thing. Faraday says that the induced EMF is not proportional to the flux. He said it is proportional to what? To the rate of change, the speed of changing, of magnetic flux. So the speed of changing, see, this one will rotate like this, the speed. So now, here comes the most beautiful differential calculus, the one I did yesterday. See, this is the area. So now we will come to this. See here. This is the coil. This is the coil. I didn't draw the output. Leave it. That is not important. This is angle theta. B is at angle theta, and this is L. This L is not changing, but B. When it is perpendicular to this, B is maximum. So the area is B into L. When it is 0, B is 0. Because why? It is parallel. Because angle theta is 0, so B sine theta is 0, so the area is 0. Now theta will be what? Now, the theta will be now, because it is rotating, this theta will vary with time. So theta will be omega t. What is omega? The speed of rotation of the coil. Remember that. Theta here is omega t, where omega is the speed, the angular frequency of rotation with respect to time. So here you got what? You have what? So B is the breadth. So B sine theta is variable. This L is not changing, so the width is changing. So what is the area? The area will be L into B sine omega t. So B sine omega t is the flux. The field strength into the area. What area? LB sine omega t is the flux. Now, what is important? Faraday say the rate of change of magnetic flux. And what did I tell you yesterday? D of this, dt of the flux will be now what? D dt of LB sine omega t now is what? D dt of LB sine omega t into F, where F is the magnetic field. This one now is no longer sine omega t. Do you remember yesterday? D dt of sine x is cos x. So now d dt of B into L into sine omega into F, where F is the magnetic field, become now BL cos omega t into F. So F into BL, so FA cos omega t. This explains this, see? This explains this. When theta is 90 degree, when theta is 90 degree, cos 90 is 0. Here, theta is 0, cos 0 is maximum. Here, same thing. Now, this is theta is 90 and 0. And this one, theta is 0 maximum. But see the difference? Here, PQRS, and here now, see from here, up there, PQRS, and here now, PQRS. This is the reason why this is plus, and what we get from the voltage from here should be minus. So if you consult your CBSE book, by now you'll understand. Why when it is maximum, this is 0? Why? Because the rate of change, d dtt of sine omega t become cos omega t. So this explain this explains this explains this one, and this minus here explain this one. So this is the most important one, and this is how electricity is generated. But let me tell you, in hydropower or thermal power, it is not the coil, it is not the armature which is rotating. The armature is fixed and the magnet is rotating and it is changing the flux. Same thing as here, but the magnet is rotating, the coil is fixed. Same thing. The magnet rotates, the coil is fixed, or the coil rotate and the magnet fixed, so you will get electricity. And these are the slip ring, and these are carbon, so that you can tap the voltage from this. See, spring is there to press. So good night. This is the most important one. I will do it again, a sort of revision with some problem. Thank you.